Hey everybody, this is Garrett with Earth and Time, and today I'm really excited about taking you all on this adventure. We're going to go through what is known as the Virgin River Gorge and check out a really unique geologic province, and that is the transition zone between the Basin and Range to the Colorado Plateau. So with that being said, let's get to it. Welcome to the stunning scenery that is the transition zone between the Basin Range and Colorado Plateau. Now I'm standing in Arizona, and we are looking at what's known as the Virgin Mountains, panning towards what are known as the Beaver Dam Mountains. Now the zone is quite wide. It actually extends from here past the St. George area, but you can really see how dramatic that change is by going through the Virgin River Gorge, and in less than about a 10-mile section, we can actually see those differences. In fact, we can point out right away, right now, where we can see how all these units in front of me, these mountains in front of me, are all tilted back this direction, dipping down towards the west. So let's get on the road and let's go head up to the Virgin River Gorge. Now we've pulled up just outside the entrance to the Virgin River Gorge. And what I want to point out here is some of the observations that we saw from farther away, but now we've moved closer. So the first observation I really want to zoom in on is looking at the dipping stratigraphy again, and specifically how we can see a change where we see these dipping rocks and we pan down towards the west, and we can see there's a change in overall topography there. And where that change takes place is where there is a normal fault, which is what helps set up the Basin and Range. So this is a quick schematic or drawing of the Basin and Range, and what I've done here is drawn using a series of faults, a range and a basin, and along these faults, we call normal faults, you drop one side of the topography down relative to the other. So the range on the right hand side would be similar to what we see in the rocks that we were just looking at, and then the basin would be that area we panned off to the west. And this is a nice view of what you see in the Basin Range, this repeating, faulted, tilted topography. If we look back over again, now we can really see that range is that peak that we see off in the distance, and then we come down and now we can start seeing where the basin is, which means there's a fault zone that runs right through that area. Now, we can see how these beds are dipping along towards that fault zone, so the faults help set up these dips that we see. And where we can see the fault is right here where there's a change in color. So we'll see there's gray on either side, and then there's this brownish, purplish, tannish colored section, and that's actually the fault running right through. Welcome to the first stop within the gorge, and we're along a section where we have pretty steep cliffs, which you can see behind me across the road, as well as if I turn around and we look up, I've got to go all the way down so we can see the top of this thing several hundred feet above me. Now, what makes this part of the gorge so narrow and thin is a couple things. One is there's a river running through here called the Virgin River, and that's why it's called the Virgin River Gorge. I'm hoping we'll get a chance to look at the Virgin River somewhere if I can find a safe spot to do that. That river is slowly cut through this landscape as these mountains have raised up. It's continued to carve a path across this section, which is why back in the 60s and 70s they built this road through this area, and at the time it was actually the most expensive road or expensive highway built per mile back in the, I believe it was the 1970s when I-15 was taken through here. And speaking of the highways, you'll see these striations going all the way up. Those were actually drill holes where they put dynamite. They drilled these holes, put dynamite down those holes, and blew off this whole side of the rock so that way they could build the highway. And you can see they extend pretty far down. This was a really major project for its time. As I continue walking along this cliff face, there's a couple observations I want to point out and then talk a bit about the rocks. One is right here is a fantastic example of a fault. So we can see this brown layer on the right hand side, and we can see where the top of it is up there. and there's a crack or a fracture here, and then we can come to the other side and see this brown layer again. In fact, we can see it kind of step down over and over again. So what are we looking at here? We're actually looking at a fault, and this is one of those normal faults that I was talking about. And what happens on these fault zones is you'll see the rock gets really ground up, and we call this a breccia. And for those of you who saw my short video earlier last week, I talked about how some of these breccias and these fault zones host things like copper deposits. So this was a nice cross-sectional view of what one of these fault zones look like. Now, this one doesn't have any mineralization, but it is really neat to see. And a nice example of a small, normal fault. So what kind of rock are we looking at here as we enter into the Virgin River Gorge? Well, we're looking at a limestone. So limestone, most people are familiar with. It's where you get things like lime for concrete. But limestones represent a time and a place within Earth, in Earth's history, where you had a warm environment generally, and you had precipitation of basically a bunch of corals, and you can think of kind of tropical environments, things like Hawaii or the Caribbean islands. And so they'll produce a lot of these, what we call carbonates or limestones. And in this case, we have a combination of both limestones and what we call dolomite, which is a derivative of limestone. I wanted to get up close and see if I could find some fossils. A lot of times these limestones have fossils throughout them. However, this rock has been so beaten up between, of course, the creation of this road and the faulting here, because we are still pretty close to where we came in at and where we saw the fault off to the west there. Looking across to the north, we can make a couple observations. One is you can see how these caves start developing within this limestone, which is something else. Even if I wasn't able to walk up to the rock, I would know this is limestone. We get what's called karst topography, or dissolution of limestone. That's why you get the caves, things like Mammoth Caves and Carlsbad Caverns. Limestones are easily eroded through water and eventually create these kinds of almost otherworldly looking structures, and we get the famous things like all those caves I mentioned before. The other thing you can see here is you can see the dipping stratigraphy, or the rocks dipping. So all the rocks are dipping down, and they're dipping fairly steeply. I would say probably 20 to 30 degrees down. Now, we know from the principle of original horizontality that when these things were deposited, they were deposited flat. Looking at these, I know something's rotated all these rocks, and we already know there's faulting here because we've seen evidence of that. So that faulting, those series of faults have rotated these rocks and continue to offset them. And with those faults here, I mentioned the karst topography, those faults also help set up pathways for fluids to migrate through the rocks and dissolve more of the limestone. So a lot of times along fault zones, like we can see here, you actually see a lot more dissolution, a lot more karst topography in these limestones. So I mentioned these were limestones, and I mentioned they're formed in a tropical sea. So you have to ask yourself, well, Garrett, you're in the middle of the desert. How the heck does that work? Well, it turns out that there's a tropical sea here. Wait for all the road noise. Back before the time of the dinosaurs, in a period we call the Paleozoic, that started over 540 million years ago and went up to about 245 million years ago. So there's about 300 million years there where the environment was very different than it looks today in this part of where I'm at, Arizona, Utah, Nevada boundary. And what you can see is there was a lot of deposition here through time by those limestones. These cliffs all the way up over here are limestone all the way up towards the top. Pretty impressive, and a lot of deposition, and probably a long period of time that this part of the United States was sitting in this tropical warm environment. From here, let's work our way up the road a bit. Let's see if we can see the Virgin River. Let's see if there's any differences that we can see in this limestone and dolomite as we continue heading northbound on I-15 through the Virgin River Gorge. I moved up the road a ways, maybe a mile or so, maybe a little bit less, but all I can say is, wow, look at this view, look at these cliffs. Absolutely stunning. If I look at the cliffs on the south side of the road, we see a lot more, again, of this limestone and dolomite going all the way up there. And I'm guessing that's probably 800 feet, 1,000 feet above me. That is an impressive amount of limestone and dolomite that is created here. The other observation we can still make is if I zoom in on the peak with the clouds on it over here, as I mentioned before, it's drizzling here and it smells fantastic. We have these dipping beds and we can see they're actually kind of dipping and rolling towards us. So there's a couple things going on in this area. So I mentioned the normal faults, and there are normal faults cutting through here, but there's also some other types of faults that have helped set up some of the observations that we can see with the dipping stratigraphy, and those are called thrust faults, and those are related to a big, what we call orogenic event or mountain building event that happened here during the time of the dinosaurs. The Basin and Range initiated roughly 15 million years ago. You started getting some faulting through this area, and of course it's continued to today. You actually have faults still moving in the Basin Range as this whole part of Nevada into Utah and into California continue to be extended or pulled apart. So much like we think of San Andreas for modern day earthquakes, places like Utah and Nevada have earthquakes and have actually had some pretty good sized earthquakes, at least in the last 100 years, and will continue to have earthquakes through time. I'm going to move my way up to an area known as Cedar Pockets. Now this is a rest stop here in the middle of Virgin River Gorge. In fact, I believe they have camping there as something you can do, and they have picnic tables. We'll go take a look at all that. But more importantly, what we're going to see is a change in the geology. We're going to see a change from these massive limestones, and we're going to see a change in how these rocks are looking, as we can see these all dipping down behind me. Let's see if we see something similar once we get up there and start talking about this idea of this transition zone from the Basin Range to the Colorado Plateau. I ended up stopping a little bit sooner than I was planning on at Cedar Pockets because I saw this turnoff and I wanted to show you all the Virgin River, and this is a great spot to really see that transition happening between the dipping stratigraphy or rocks of the Basin Range to the flatline rocks of the Colorado Plateau behind me. However, before I get there, I wanted to show you the Virgin River, which is the river that carved this canyon. You'll see there's some water in there. It's not as high as I've seen in the past, but it's a pretty steady flow. And you can get little areas where you get some mini rapids going on. And during the summers, I know people will come here and they'll tube this or swim in the river. It's a really pretty place to come visit, and a great place to cool off when you're driving through this area if you can find some access. The other thing to point out here is that we still have these large, massive limestones behind me, and we can continue to see those here with those dipping beds. And as I mentioned when I first stopped here, we actually have a change where we go from these large, massive dipping limestones to these relatively flat lying rocks that we'll take a look at when we get up towards and talk more about once we get up to Cedar Pocket. I really do get constantly, as we call it, squirreled when I'm looking at geology. As I was getting ready to head up to Cedar Pockets, I noticed this feature. Now, hopefully all of you, because I explained what kinds of features are setting up the mountains here, and we talked about this type of fault, you all recognize what I'm looking at here, and that is there's a fault zone or fault line right through there where you can see this more, what is this, kind of a tannish, brownish rust color to light green geologic unit here, which I think is from what we call the Devonian, or the time of the fish, over to the other side where we can see it's just all of this gray limestone. So there's a beautiful fault running right through there that this road cut exposed. Going to try to not get distracted again and work our way up to Cedar Pockets. I moved about a mile up the road, got onto the Cedar Pocket off-ramp, and wanted to stop and show you in that short distance, oh, how the world has changed in many, many different ways. As I turn around and look from the direction I just came from, we can immediately see there's a bunch of red rocks now, and if you all remember, we were in those gray limestones off in the distance. So two things have happened. I've come up in elevation as well as in geologic time, and I've changed environments as I was coming this direction. What we can see here is a bunch of red sandstone, and those of you who visited southern Utah before or places outside Las Vegas probably recognize red sandstone because you see it quite often there. What's different about this is this isn't part of that Navajo sandstone or Nugget or Aztec sandstone, depending on where you're at, that make up Zion National Park. This is a much older sandstone from before the time of the dinosaurs, which is really interesting and also represents a time where we ended up in these great sand dune type or Sahara Desert type environments. I've turned and faced the north from where we were looking at that red sandstone, and I want to point out that we can still see the limestone and the dipping stratigraphy. If we look at the limestone here and I turn to my right, we can start seeing a lot more sandstone. Now, the sandstone over there is white as opposed to what I just showed you, and the reason for that is because we are along a pretty major fault zone here, which is putting the limestones, which are much older, against the younger sandstones, even though they're at the same relative elevation coming through here. And that's part of what a normal fault does. Okay, I'm trying to do this in the back of the trunk because it's starting to rain out here, so I hope this comes out okay. So what we're seeing is we drove in from here in the south, drove across that main fault zone. We've come through this block of limestone, right? And with that, we know we saw a series of faults by making a basic cartoon. And now we've come to an area where a fault has brought the sandstone down that would have been sitting on top of this limestone down at an equal level to the limestone. So a pretty major fault had to drop this down. We know the sandstone is younger than the limestone because we can look in other areas where we can see a nice flat stratigraphy in places like the Colorado Plateau that we're transitioning into. So we can start putting together how these should be lined up. So when I see two different types of rocks next to each other, and especially because I know they're different ages, I can start putting together a story of what kind of fault I have here. And again, I have another normal fault that's dropped the sandstone we looked at down against that limestone. All right, with that, let's talk a little bit about Colorado Plateau stratigraphy and the layering there and why it looks different from what we've seen before. All right, so what makes the difference between what we're seeing in the Basin and Range to the Colorado Plateau? It really comes down to what we're looking at with how the layers are dipping and how the faults are interacting in this area. So there's not a lot of normal faulting in the main part of the Colorado Plateau. Now, there are faults there. The Colorado Plateau is just a broad uplift of kind of the central portion of the western US. It includes places like Utah and Arizona and Colorado and New Mexico that brought that whole area up, and we'll talk about that another day. But the important part is we go from an area, if you remember with the Basin Range, where you have a bunch of these faults and a bunch of dipping stratigraphy, to an area with fairly flat stratigraphy. And I drew a little canyon in here, and we can draw a little water, maybe down in there, happy little water. And it gives you an idea that what we'd expect to see is flat stratigraphy. Now, with this flat stratigraphy, we can start understanding what the relationships of each of these rock units are. So as we move into the Basin Range, or vice versa, Basin Range here, we can start putting these things in order and understanding how they moved relative to one another in these faulted terrains. Cedar Pockets, where I just pulled over at and we're going to continue on to, into the main part of it, is a great example of where you see that transition where we were at those dipping beds, right? So if I was putting something here where I had this dipping stratigraphy, and sorry, the board is getting wet, so it's getting harder and harder to draw. Let's see what other colors I can use here because of the rain, right? So I have this dipping stratigraphy, and now suddenly I'm in a different place. Oop, there's my little fault zone, where I'm going from this dipping stratigraphy and this faulted terrain to where it's fairly flat lying. Now, there can be some faults in here, but there's not nearly as many, and we don't see as much deformation. All right, let's go take a look at this nice view of this transition zone here in Cedar Pockets. And welcome, my friends, to the Colorado Plateau. So this is literally the transition from the Basin Range to the Colorado Plateau right behind me. Now, geologically speaking and geographically speaking, there's a zone or transition zone. It really goes from here all the way to the town of Hurricane, which, if any of you have gone to Zion National Park, is one of the towns you drive through on your way there. So it's, I don't know, is that about 30-mile, 40-mile wide zone here. But this is the first view as you come out of the Basin Range of this flat line stratigraphy associated with the plateau. And again, you can see how high these cliffs are. These are probably 1,000 feet or more, so 300 meters plus up there. And what we can see is a variety of different geology than we saw as we were entering into the Virgin River Gorge. And what we can see is we start picking up this section of sandstone known as the Quantaweep, which is one of these old desert environments that existed here post all those tropical seas. Now, what happened after that is we'll see there's a thick succession of this Quantaweep. We get into what's known as the Toroweep, and we get into all the way up above what we call the Kaibab limestone. And so we actually get back into more of a terrestrial environment. So we go from marine environment to a land, or what we call terrestrial environment, to more of a transition up into another marine environment where we end up having limestones on the top of this section. Now, these limestones are much younger than the limestones we were seeing across the way, which again gives me a hint that there must be a big fault that comes through here and it's dipping down towards me. I'm going to go ahead and just pan across this first view when you come through this gorge and you see this flat line stratigraphy and you see the classic red rocks of the Colorado Plateau. Now, this would be a really old section compared to a lot of the things you see in the Colorado Plateau. Most of those were deposited during the time of the dinosaurs, and the rocks you're seeing here are still pre the time of the dinosaurs. Pretty interesting. From here, we're going to try to avoid running into this cholla cactus, which are nasty. And we're going to go head up the road, continuing north towards St. George, Utah, and we'll pull off up there and we'll do a little wrap up as we get to that side. If you ever visit this area, it's $2 for day use here, and I believe I saw it was $8 for camping here at Cedar Pocket, which would be a great place to come camp. Maybe not in July or August, but probably the rest of the year be pretty nice. In fact, even right now, and we're in what, January 2024, it'd be worth coming to visit and camping here. All right, let's get up the road. And I got squirreled again. I started realizing that this really is the first time as you come from the west, come from California or southern Nevada, that you really get to see the flat line geology that is the Colorado Plateau, and how really cool and unique that is that we can come to this spot and see it. Welcome to the other side of the Virgin River Gorge. We're just outside of St. George, Utah. And a couple of things to point out here as we come over is that you can notice the pretty benign topography, if you will. We don't have the big mountains we saw on the other side where we first entered. The stratigraphy is fairly flat. There's a little bit of a dip to the stratigraphy, but not nearly as drastic as we were seeing on the other side, because now we are into that Colorado Plateau region. And we can really see there's not a lot of topography popping up through here. Now, that being said, on a non-cloudy day, there is a big mountain range over here called Pine Valley Mountains. That's actually what we call a laccolith. So a little bit different than the Basin Range mountain building that we talked about before. But you can look at the marked difference here from where we started in the gorge with those big mountains and normal faults to being on top of the Colorado Plateau. Pretty cool. Thank you everybody for joining me today as we traveled and traversed from the Basin Range to the Colorado Plateau, an area I like to call the Great Transition Zone in this part of the southwestern United States. I hope you enjoyed it as much as I did. I hope you learned just like I did, I saw some new things there, like one of those faults I got squirreled by I've never noticed before. I was very excited to see that. With that being said, if you enjoyed this video, make sure to give it a thumbs up. And if you haven't already, please subscribe to this channel and hit that bell for notifications so you can keep up on all my videos. I will catch up with you all on my next adventure. I look forward to seeing you all there, and take care. One thing I will never get sick of are the amazing sunsets and skies here in the southwestern US desert. Absolutely stunning.